So admixtures are substances which are added into infusions to be delivered to the patient. For instance, drugs such as insulin, vitamins and minerals, antimalarials have the tendency to be put or to be added into infusions to be delivered into the patient because of several practical reasons. So due to that case, they are regarded as parenteral admixtures, meaning they are administered by any other route apart from the oral route. So when they are administered into such fluids, that's when we call them admixtures. So we need to know the principle behind the operation. What do we actually consider before we add them into infusions? So they should correlate to the dose of a specific patient. That's what we are going to learn. We are going to see how you can calculate the correct amount of admixture into the intravenous infusion. Let's check this example. So a medication order for a patient weighing 154 lbs, meaning 154 pounds, calls for 0.25 milligrams of amphotericin B, this is an antifungal drug, per kilogram of body weight to be added to 500 ml of 5% dextrose injection. If amphotericin B is to be obtained from a constituted injection that contains 50 milligrams per 10 ml, how many milliliters should be added to the dextrose injection? So to know this question, to be able to solve it, you need to have information about the medication, information about the patient, and information about the fluid. Having known that, you will solve it in a simple and clear manner. Follow me. You are going to understand this in less than 2 minutes. So, our infusion, this is dextrose 5%. Then we shall have information about the patient and information about the substance to be added into the infusion, that is an admixture. Okay, so a medication code order for a patient weighing, so a patient weight is equivalent to 154 lb. When you change into kilograms, you divide by 2.2, that is probably 70. Okay, that is 70 kg for a patient. Calls for 0.25 milligrams of amphotericin B per kilogram of body weight. So the dose for this patient is 0.25 milligrams per kg of what? The admixture is amphotericin B. Okay, to be added. So this dose, after calculating the required amount of dose, should be added to the infusion, which is the volume of infusion is 500 ml of dextrose infusion. So if amphotericin B is to be obtained from a constituted injection, so available we have a constituted injection of amphotericin B with the following strength: 50 milligrams per 10 ml. How many milliliters should be added? So we need to know amount in mils of amphotericin B to be added to dextrose, then delivered to the patient. First step, you need to know the total amount of drug to be consumed by the patient. Okay, the usual dose for this patient is 0.25 milligrams per kg, but this patient has got a total kg of 70 kilograms. If we multiply, you get 70 point, probably 0.25. That is 17.5. That is 17.5 milligrams. So this patient has to use 17 milligrams of amphotericin amphotericin B. But how do we get 17.5 milligrams of amphotericin B? Is from this constituted injection which is available. So from this concentration of the injection, 50 milligrams are contained in 10 mils. Then 17.5 milligrams required are contained in how much mils? Then multiply by 10, divide by 50. This is 3.5 mils. Okay, the practical implication of this, how do we do it? We have got 3.5 mils of amphotericin B. So take a syringe, maybe a 5cc syringe, then draw 3.5 mils. Draw 3.5 mils of amphotericin B from this injection and deliver it into this infusion, and thereafter run the infusion to the patient. Let's have two more examples, then we quit the session. This was an assignment in one of the classes. An intravenous infusion is to contain 15 milliequivalents of potassium ion and 20 milliequivalents of sodium ion in 500 mils of 5%. Using potassium chloride injection containing 6 grams per 30 mils and 0.9% sodium chloride injection, how many milliliters of each should be used to supply the required ions? So we have the infusion here. Probably this was dextrose 5% with the volume of 500 mils. But this infusion was to contain an admixture of the following: potassium, and sodium. These are the two admixtures which were to be added into this infusion. So how much of each? To contain 15 milliequivalents of potassium and 20 milliequivalents of sodium. Okay, so available drugs are in terms of injection. So the potassium chloride injection, we have the potassium chloride injection with a strength of 6 grams per 30 ml, and sodium chloride injection 0.9%. 0.9% meaning 0.9 grams in 100 ml. Okay, how many milliliters of each? We need to know amount of each in mils, which are to be considered as an admixture. How do we do this? We need to consider the concentrations given. The first concentration is about potassium chloride. So let's solve the amount of potassium chloride. So potassium chloride, the amount of potassium to be issued can be obtained from potassium chloride. So its concentration from the injection is 6 grams into 30 mils. Then how many milliequivalents are required? 15 MEQ are contained in how many mils? So how do you do this? First, convert milliequivalents into grams. How do you do this? Remember, 1 milliequivalent of potassium chloride is provided by 74.5 milligrams. So 15 MEQ are provided by how much? So this is 15 times 74.5. Then that is 1117.5 milligrams. Converting into grams divided by 1,000. Then that is 1.1175. Okay. Then put here 1.1175 grams, multiply by 30, divided by 6, that is 5.5 or 0.6 mils. Okay, to know amount of sodium to add, so sodium can be obtained from a sodium chloride injection. with a concentration of 0.9 grams into 100 mils. Then 20 MEQ can be obtained how? Then 20 MEQ should be converted into grams. Remember that 1 MEQ of sodium chloride is provided by 58.5 milligrams, and 20 MEQ shall be provided by this. Okay, this is 58.5 times 20 MEQ. Then this is 1170 milligrams. Obtaining grams divided by 1,000. If we divide it by 1,000, that is 1.17 grams. Okay, then substitute grams here. Substitute 1.17 grams. If you multiply by 100 divided by 0.9, you get 130 mils. So 130 mils of sodium will be drained from here, and 5.6 mils of potassium shall be drained and put into an infusion. The last example states that a person is to receive 2 milliequivalents of sodium chloride per kilogram of body weight. If the person weighs 32 lb, how many milliliters of a 0.9 stellite solution of sodium chloride should be administered? So this person, this is the dose now. This person was to receive 2 milliequivalents of sodium per kilogram. Okay, if the patient weighs 32 lb, weight of a patient, this is 32 lb, converting to kg, probably 14 point something, divided by 2.2, it is 14.54 kilograms. Then the available injection of sodium chloride is 0.9%. So first we need to know the total milliequivalents which is consumed by this patient. So 2 milliequivalents were to be consumed by a 1 kg person, but this person has got 14.54 kilograms. So how much milliequivalent should be taken by this patient? This is times 2, you get 29.09 milliequivalents. So these are the total milliequivalents to be consumed by this patient. So convert these into grams. Remember, this is sodium chloride. 1 milliequivalent of sodium chloride is provided by 58.5 milligrams. So 20 what? This is 29.09 MEQ of sodium will provide how many? So multiply by 58.5. This is 1701,818 MEQs. 1 MEQ 58. That okay. 58.5 times 29. Okay, those are milligrams. To obtain grams, divided by 1,000. Then that is 1.701 gram. Having known that, from the injection available, which is 0.9 in concentration of 100, so what about 1.701 gram? This will be found in how much? Then that is 189.08 mils. All right. That is all about intravenous admixture. You may have more practice questions. I'm Mr. Laidan from Spring Institute.